Hello everyone and welcome back to Unit 2 of the iGCSE Computer Science syllabus. We are currently looking at data transmission, and in particular in today's lesson we will look at the methods of error detection and how we find errors when we transmit data. So we are currently here in the syllabus, Unit 2. So far we have looked at how data is transmitted in terms of either serial or parallel, and also the terms simplex, half duplex and full duplex. So if you are unfamiliar with those terms, please go back a lesson and watch the video on that. And we have also looked at how data is transmitted over the internet in the form of packets and how packet switching is used to transmit data via the internet. So in today's lesson, we are going to look at how we detect for errors, and we are going to understand the need to check for errors, so why we have to check for errors, and also how they can occur. So what kind of things can cause errors in data transmission and cause problems with data that is sent over a network. And the methods of error detection that we will look at today are checksums and check digits. So just in this video, we are going to look at checksums and check digits. All the other types with parity checks and echo checks we will look at in a future video, and also this term ARQ. We won't be looking at these in this video, but be sure to watch the next video where we will look at these terms there. So errors can occur when transmitting and storing data. So this word transmit, we've said a few times now. We can transmit data over a network via the internet. We can also transmit data from device to device using a cable. We've also looked at the term USB is another method of transmitting data. And also this term storing data would apply to the same thing. Okay, once data is being stored from one place to another, we would transmit it using any of these methods. Now, what can cause data to become corrupt or to make it inaccurate, as we say there? So inaccuracies, meaning it's not the same from when it was sent to when it was received. Also this term unreliable. So the data isn't what it's meant to be when it's on the receiving end of a device. Now, a few problems that could occur. Now, electrical interference mainly applies to wireless transmission. So if we are transmitting data over Wi-Fi or Bluetooth, if the distance is too far, or there's large solid objects in the way. So for example, if you're at home and you've got a solid brick wall in between two rooms, the Wi-Fi might not reach that next room. That could cause problems with our data being sent. We've also got power surges, where there may be a problem with the electricity in the building that you are in, and there could be a sudden surge of electricity causing the data to become corrupt. So again, the binary numbers that we've mentioned in Unit 1 don't add up to what the data should correspond to. Also, this one fairly straightforward and obvious, damaged cables or connectors. As you can see there in the image, this cable is clearly damaged and this would cause problems with data transmission. Here you can see the actual metal of the wire exposed, and the same thing would apply on the end of the cable where the connection attaches to the device. So a USB cable, for example, or a USB pen drive. If the connections on the actual device are damaged, then that could cause problems with data being sent. Now, the two biggest things that will happen to our data is that it'll either be lost or it will be changed. So they are the biggest problems that we have, that the data is being sent and it's not the same as it was when it's on the receiving end. Or even worse, it's completely lost altogether. And you may have experienced corrupt hard drives or corrupt USB drives where you've put data onto a USB drive and all of a sudden it's gone. So the way in which we check for these errors comes in a number of different ways. The ones that we are going to focus on today are checksums and check digits. Okay, these three we will look at in future lessons, so bear with me. But for today, we're just going to look at checksums and check digits. First of all, we're going to look at checksum. Now, we have a scenario here. Imagine you're sending a package to a friend, and before you send it, you take a picture of everything inside and put it in an envelope on the top. So you take a picture of the contents of the box and then send the box along with the picture to your friend. Your friend receives the package, they look at the picture, they check inside the box, and if everything matches, everything's been received as it should. If something's missing or there's something in the picture that isn't in the box, you know something might have happened in the delivery and they may ask you to send it again. So with this in mind, the same thing's going to apply only with numbers. Remember, Unit 1, binary numbers is everything that we're dealing with in terms of a computer and digital data. It's all ones and zeros. So if any of these ones or zeros go missing or change, then it's not going to look just like the box as it should be in the picture. And here's what actually happens. The file is run through an algorithm that produces a checksum. So it produces a number, okay? Checksum is a number that is sent along with the file. So all these ones and zeros represent numbers and they are run through an algorithm, a set of instructions. When that file arrives on the other end, The computer generates the checksum and compares it with the checksum that was sent. So the receiving computer will run the same algorithm as it did when it was sent. So the same algorithm is applied on both ends to see if the number matches. Okay? Now, if these numbers don't match, there's clearly an error and the file might have been corrupted or altered in some way during the transmission. So in the diagram below, we're going to start off with this one here. Okay, this is the file that we're sending. The original message contains the number 143658. So this is the original message. Now this number, like I said, goes through a set of instructions. It might be to add all the numbers up and divide them by a certain number, but either way, a number is produced. Now in this example, the algorithm produces the number 9. So the number 9 is produced from some instruction that this number goes through. So as you can see, the message with the checksum is 9143658. The computers will know that this is the data and that this is the checksum. The file is then sent over the internet. The received message is here, and the same checksum algorithm is applied to the number, to the received message. Then it will check the number at the end, the checksum, and it will see if they match. And if they do, the file has been sent successfully. If any of these numbers are changed in the process, so this 8 is changed to a 7, for example, the number 9 won't be produced. The algorithm will produce a different number to the 9. So this wouldn't match up, and we clearly know there's an error. Now, check digits work in the exact same way, but these are used to check when data is input to a system rather than sending it over the internet. And that's one of the biggest differences between the two. I often have students who get confused between the two. As long as you associate checksums with going over the internet, then you should be able to remember that check digits are used for data being input to a system. As you can see on the screen, barcodes or ISBN numbers, which is for books, when we're typing these numbers into a system, it will perform a check digit to see if the number is correct. Now, the process involved is very similar to a checksum, and it's why students always get confused. A specific calculation, in other words, an algorithm, is applied to the number. Okay, so you could see here that this is the number, and this could be a check digit. So the original number goes through a specific calculation, goes through an algorithm, and a check digit is produced. Now, common examples of where this might be used, I've mentioned here: barcodes, ISBN numbers, and bank account numbers. When we are inputting these numbers into any sort of system, the number is run through a check digit, which will make sure that the whole number is correct and that the number matches whatever it is that you're typing in. So now we'll run through an example of how a check digit might work. In this example, we're working with an ISBN number, which contains 12 digits. The check digit itself is going to be the 13th digit at the end of the sequence. So we're going to put the check digit in this box. Now, the sequence of steps might change, but in any exam, you'll be given the instructions to apply to your number. So you're going to have to show some basic math skills when it comes to working out a check digit. In this example, each number of the ISBN number is multiplied by either a 1 or a 3. So we've got our ISBN number at the top, and we're going to multiply each digit by 1, then by 3, then by 1, and so on and so forth. So starting with 5, 5 times 1 is 5. 0 times 3 is 0, 1 times 1 is 1, and there's our full number complete at the bottom. So once we've got all of our results, we follow the next step, which is addition. The next step of the algorithm is to add all of the numbers. So I take all of these numbers and I add them all together, and there we have 49. So all of these numbers added up produces 49. The next step in the algorithm is to find the remainder when it's divided by 10. So again, it's just a sequence of steps, it's just an algorithm, and this next step is to divide it by 10 and find the remainder. As we know, 49 divided by 10 produces 4.9, but we need the remainder. So it will be 40, remainder 9. There we go. So 9 is the answer here. Then we subtract the result from 10. So 10 minus 9 is 1. And there we have it. The 1 is the check digit, and it is applied to the number so that when this number is input, it will run the same algorithm and see if the 1 matches, and that will make sure that the number is correct. Now, like we said, this is applied to books, barcodes, credit card numbers, could be identification numbers in certain countries, but they all do the same thing. They all check if the number is correct. If this number doesn't add up, then there's clearly been a problem. And again, to differentiate a check digit from a checksum, check digits are for the inputs of numbers into a system. A checksum is when data is transferred over the internet. So to clarify, we've got a quick definition of each one. Checksum is a calculated value from data, like a file or a message, used to spot errors or damage during data transmission, okay, or storage. This will ensure data integrity. A check digit is a single digit added to a number or code, aiding in catching errors during the manual data entry. Barcodes, credit card numbers, and other IDs are what we need to associate them with. So once you familiarize yourself with check digits being used for these scenarios, then you should be okay in remembering which one is which. And at the bottom here, we've got examples of why check digits are extremely useful when it comes to putting in numbers. Because even if you type in the wrong number, like we said before, the check digit that is produced will be different, and you can clearly see that it's an incorrect number that's been put in. We've also got the possibility of transposition errors, where two numbers have changed order. So 5037 becomes 5307, which is an easy mistake to make when it comes to humans putting in numbers. You could also put an extra digit by accident. Here you can see a zero has been accidentally put in. Or it could be a phonetic error where if you're talking over the phone, someone mishears you and they type in 13 instead of 30. So again, the check digit that is produced will be different, and we can catch the error early, okay, and make sure that we fix it sooner rather than later. So to finish off, we have an exam style question here based on check digits, and we have a 7-digit number with an extra digit on the right called a check digit. Okay, so like I said, in the exam, you'll be given a specific set of instructions to follow in order to produce the check digit. So the check digit is calculated as follows. Each digit in the number is multiplied by its digit position. So it even gives you the position of the digits at the top, but you could easily work out that position 1 is here, and so on and so forth. The 7 results are then added together. The total is divided by 11, and the remainder gives the check digit. If the remainder equals 10, the check digit is X. Check this number showing your working. So put our number here, 4241508. We'll times each digit by the position that it's in. So 4 times 1 is 4, 2 times 2 is also 4, 3 times 4 is 12, 4 times 1 is 4, 5 times 5 is 25, 6 times 0 is 0, 7 times 8 is 56. Once we've got all that, we add them all up. I'm just going to use my calculator here, and the total is 105. So we've done this and this. The total, 105, is then divided by 11, which I know 10 11s make 110, so that's too big. So it's clearly going to be 9 11s remainder something. So 9 times 11 equals 99, and the remainder will be 6. There's 6 left over. 6 add 99 is 105, which is the number that we had. So the check digit in this scenario would be set as 6. Okay, and in the answer here, check digit 6. And just to confirm, this is from the mark scheme. As you can see, the check digit produced was 6. So the same thing applies to a checksum, guys. In an exam, the checksum, you will be given the instructions to complete in order to produce the checksum or the check digit. And you just have to show your working out to prove how you got the check digit or the checksum. And that's it for this lesson. In the next video, what we're going to do is look at ARQ, automatic repeat requests, and also parity checks and echo checks, which are the 3 remaining methods of error detection in Unit 2. So I hope you've understood, and be sure to watch the next video for the remaining methods that we need to know.